It's helpful tonight to refresh your memory on how to do long division. So if you take 35,761 and you want to divide by 62, you would say, oh, well, 62 doesn't go into 35, but it's going to go into 357, let's say 5 times. So you then multiply 5 times 2, gives you a 10, carry your 1, you get 31. Then you subtract. So if we subtract here, we're going to end up with 47. 62 doesn't go into 47, but we bring down the 6. 62 will go into 476 7 times. 7 times 2 is 14, again carrying your 1. You end up with 43. We then subtract. When we subtract, we end up with a 42, and we carry down the 1. 62 goes into 421 6 times. So 6 times 2, we're going to get 12. Carry our 1. 6 times 6 is 36, plus the 1, we get 37. If I squeeze this in here then to subtract, we're going to be left with 49. Back when you were little, you'd put this up here with an R next to it, and you'd say R49. As you got a little bit more mature, you rewrote this to say 576 and 49 over 62. The other day we worked on synthetic substitution, where I would take what I'm plugging in, which is 2, I would set up this big box, and then I would put in my coefficients of my x terms. I have -2, 3, I don't have an x squared term, so I need to put 0 to hold its place, -8, and 13. We bring down our -2, and now we can start multiplying to get back in. We get -4. Combine, and we end up with -1. Multiply, we get -2. Add to get -2. We multiply, we get -4. We add, we get -12. When we multiply, we end up with -24. And when we add, we get -11. So we were able to state f of 2, the function evaluated at 2, is equal to -11. The next thing that we did was talk about our end behavior. So we would state something like, as x approaches -infinity, what's happening with our graph? Because it's an even degree with a negative in front, it's like having a parabola that opens down. So my y values, f of x, in other words, are going to approach -infinity. As x is approaching +infinity, f of x approaches -infinity as well. When doing polynomial long division, we set it up very similarly to how we did the very first warm-up on here, just like our old school division problems. Except this time, instead of trying to get a number to go into another number, we're getting one polynomial dividing into another. So I need to think, what can I multiply the x squared by in order to get an x to the 4th power? And hopefully you get the idea, we have to multiply by x squared. But where I place the x squared is going to be over where my x squared is, and line it up so that when I multiply, I have my trinomial. That's all set up here and ready to go. So x squared times x squared is x to the 4th. X squared times a -x gives me a -x cubed, and if you haven't already noticed, I put a 0x cubed since there was no x cubed term in my original expression. X squared times a +1 is going to give me a plus x squared. But if you remember, what we did in the next step of this process is subtract. So this goes back to what we did in section like 5.1 and 5.2. You can add a line and change the signs in here. And we're subtracting our polynomials. And the reason we chose what we can multiply x squared here by to get an x to the 4th power is because we want that first term to drop out. So this becomes an x cubed, and it becomes an x squared. Just like we do in regular long division, we bring down the next piece of the puzzle. So bring down your negative x. Now, what can I multiply x squared by in order to get x cubed? Well, that's going to be a positive x. So when we multiply by positive x times x squared gives me x cubed. Again, I want to match this up so that they're exact, and that way when I subtract, it disappears. X times a negative x is a negative x squared, and x times a positive 1 leaves me with a plus x. When we go to subtract, again, you can add a line, change all your signs. So our x cubes cancel out. This became positive in the next setup here, so we get 2x squared minus 2x. Bring your 5 all the way down. What can I multiply x squared by in order to get 2x squared? Well, that's going to be a plus 2. So when I multiply by 2, I get 2x squared minus 2x plus 2. If we subtract, we can add a line, change the signs. So our first terms cancel out. Our second terms actually cancel out. In this case, we end up getting a positive 3 here. And instead of writing R3 like you did in 3rd grade, we actually are going to write the remainder, so this represents the remainder, as a fraction. So it doesn't go in anymore, but we're left with 3 over x squared minus x plus 1. So our final answer then is this x squared plus x plus 2 plus 3 over x squared minus x plus 1. Okay, another practice with the polynomial long division. We're going to take our dividend of 2x squared plus 13x minus 7 and divide that by the divisor of x plus 6. So what can multiply times the x to give me 2x squared? Well, that's going to give us a 2x that we need. So we write it up over our x term, 2x. 2x times x gives us 2x squared. 2x times 6 gives me a plus 12x. We're going to subtract this expression. When we subtract, again, your trick could be add a line, change the signs of what you had there so that your 2x squareds cancel out, and you'll be left with an x. Bring down your 7. Well, 1 times x gives you an x, so we need a plus 1. We'll be left here with an x plus 6 when I multiply 1 times x plus 6. When I go to subtract, again, add a line, change your signs, and we end up with the first terms canceling and a negative 13. So our answer here is 2x plus 1 minus 13 over x plus 6. Synthetic division is based off of synthetic substitution that we've been working on. If f of x, some function, is divided by x minus k, then the remainder that we were getting that plus whatever over and getting the fraction there, the remainder is going to be the function evaluated at k. Think about it though. If x minus k is equal to 0, then x is equal to k. So the k value that we're looking for is going to be the opposite of the sign that you see. For instance, in our problem that we have here, x minus 1, my k value here is actually a positive 1. So that's what I want to put on the outside of my synthetic division box. Bring down the first one, multiply, and you get 1. That drops out to give you a 0, so 1 times 0 is 0. Bring this down, you get a -2. Multiply, -2 pops up there. And then when we combine, we end up getting 6. So here's the cool thing. The function evaluated at 1 is 6. You guys know that from what you did this past week. But what we didn't tell you is if you're dividing an x cubed by something that has an x to the first power, what should you be left with? Yep, an x squared. This represents your x squared term. It goes down 1 degree from your original problem, and then it filters in from there until you get to your constant. Oops, and your constant's actually going to be here. Here is your remainder. So we can actually say when we divide this, our answer is going to be 1 x squared. There is no x term because we have a 0 here, minus 2 plus 6 over what we were dividing by, which was x minus 1. And there you have synthetic division. All right, for this problem here, we have x minus k being represented by x plus 2. So x minus what would make it into x plus 2? And that's just further realizing that we should have a -2 out in front. If we put our coefficients in here, we've got a 1, we have -1, -2, and 8. We're not missing any terms here. Bring down your 1 and multiply times the -2. We now have -3 when we add. Multiply to get a positive 6. Combine, we get a positive 4. Multiply, we get a -8. And combine, we get a 0. What that means is that there is no remainder. In other words, one polynomial divides evenly into the other and is therefore actually a factor of that polynomial. So if we want to rewrite this piece here as our polynomial for the division, we go down one exponent. We had an x cubed, it's now an x squared. So we have x squared minus 3x plus 4, and there's no remainder here to deal with. So that's it. In this next problem, we're dividing again a third-degree polynomial by a binomial. X minus 4 represents our x minus k, so our k value is 4, and that's what goes on the outside. Always the opposite of the sign you see inside the parentheses. Bring down our 1, 4 times 1, we get 4. Combine to get a 1, and we get 4 again. Combine, this time we get a -3. 4 times -3 gives us -12, and combine to get a -6. So if we started with an x cubed, that means we're now dealing with an x squared and working our way down from there. So we have a 1x squared plus 1x minus 3 minus, and here is our remainder, 6 over x minus 4. There are two problems that I have here for you to try on your own. The first is using the long division, and the second is using the synthetic division. So at this point, please pause after you write down the problems and try doing them. Then you can hit play again and check out your answers, make sure that you're good to go. You can also rewind at this point and check the previous problems if you need to go back and refresh those. Okay, here are the answers for the last two problems. If you did not get these correct, go back, try them again until you can get them. We can start class off tomorrow by going over these two problems on the board, so if you're really stuck on it, don't sweat it. We'll go over it and we'll get you there.